All right. So, hi everyone. A very good morning, good evening to all of you. This is Manish Agrawal here, co-founder of Axelta, and welcome to the webinar on IoT solutions. And more precisely, uh, your path for a rapid and a cost-effective IoT solution. So we'll be spending almost like 1 hour talking about various different use cases. I'll share some of the work that Axelta has been doing in that space, and try and understand the challenges that come across for building IoT solutions, specifically for B2B, but could be relevant for B2C scenarios also. So, Axelta, we are a 4-year-old organization focused specifically on IoT solutions. We work with corporates, business entities, and individuals for digital transformations, building specific IoT solutions, as well as in enterprise IoT. A quick look at our profile. That's me. Uh, I've like almost 25 years experience in the IT space. Initially in the software, but for last 4 years, I've been focusing on the IoT, industrial IoT, and such kind of application areas. That's my partner and co-founder, Piyush. He spent again quite some time in the IT space, and both of us started this organization called Axelta somewhere around 2013. Over the last 4 years, we've had certain recognitions by a lot of renowned entities, including by Economic Times. Uh, okay, so Dilip is not able to hear. Others, I hope you are able to hear me. Okay, he might be having some issues with the audio, but let's proceed further. So work with a lot of different businesses, entities, and all, both from a general awareness on IoT is concerned, as well as with consulting. We consult with a lot of organizations on how they can develop the IoT practice or IoT solutions within their businesses, build proof of concepts for them, as well as deploy full-fledged in the production space. Now, in terms of our offerings, this is how it looks like, and this is how the path goes about. IoT being one of the, you know, newer areas, a lot of entities and businesses, they are not really sure how to go about. In fact, individuals also looking at building a career in IoT have often this challenge. So what we do is that we start with knowledge sharing first. Through various mechanisms, we conduct boot camps with the businesses and individuals. We do workshops which are focused on brainstorming to understand what kind of challenges they have, as well as defining certain path for them on the IoT journey. Once we've done that, we get into the consulting mode, wherein we help define the road line for them to bring in IoT in their manufacturing process, in their business processes, as well as in their products, because connected products is the way forward. So we help develop that strategy in that process. The next stage of our engagement is to kind of try and get some low hanging fruit. So create some POCs which are low cost and low risk, get the business to feel how that engagement can work, how that IoT can transform their businesses, define certain return on investments that they are making, help build budgetary estimates, because IoT is more of a journey than a one-off kind of an implementation. So help create fiscal-based budgetary plans for them, as well as define some outcomes and prioritization on how do you go about. And eventually we get engaged deeper in the corporate, in the manufacturing companies, where we do solutions in industrial IoT, connected products, as well as in enterprise IoT. These are some of our partners that we work with. Some of them are hardware partners, some are software, some communication protocols and communication network. And we also work with management consulting for providing technical solutions with them. Now, this is how the entire ecosystem, which enables us and businesses to rapidly go about and build solutions which bring in advantage to them in a quick as well as a low cost manner. So this is a full-fledged ecosystem that Axelta over the last 4 years has created, which enables that. This includes a number of what we call as nodes, which has sensors connected to them. So there are certain plug and play sensors, as well as certain nodes which can be attached with different kinds of sensors that we have developed, which already have wireless communication ability in them. Now, the wireless communication could use any of these radio frequency protocols, and our hardware already has those pieces inbuilt with them. Then we also have our own gateway devices, which we use for the solutions which are able to wirelessly talk with these nodes, as well as are capable of significant fog computing, where a lot of the processing and intelligence can be fed directly at the gateway level. So there are certain gateway devices that Axelta has built based on different types of use cases, as well as there are certain gateways from organizations like Dell, like Intel and Advantech, that we have tied up with, which we bring in into the scheme of things for doing those solutions. Now, these gateways also have the capability to talk to a lot of existing SCADA deployments. So SCADA is very often used in manufacturing processes. So we can, using OPC and other interfaces, directly stream the existing data into our gateway devices for data logging, as well as pushing to the cloud platform. As well as we can, using Modbus, Profibus, RS485 and such kind of communication protocols, be able to pull out information from these industrial PLCs to be able to either process it locally or push that information across to the cloud-based platform. Now, when it comes to the cloud-based systems, which in a way form the heart of any IoT deployment, Axelta has developed its own platform called Osmosis, which has the necessary capability, including support for multiple protocols, to talk to either any of these gateway devices or some other hardware devices that the customer might want to integrate with, using various different communication channels, as well as various different protocols to kind of ingest the information coming in from these devices. Now, this platform I'll shortly talk about, but Axelta also has partnership with industry standard platforms like ThingWorx, as well as Microsoft Azure, which we use for the solution based on the requirements that the customer might have or their specific preferences. Now, this Osmosis platform can actually be either deployed on the cloud, but in fact, a number of our customers want on-premise deployment. So this platform can actually be deployed on-premise within the manufacturing or any industrial or enterprise setup to be able to take care of their data safety concerns. Uh, Now, this platform also has a number of interfaces which businesses can use for integrating with their ERP and other IT systems, as well as there are a number of out-of-box reporting, analytics, mobile apps that are available, which give us enough right building blocks to quickly go out and deploy. Now, what happens is, because we have all these pieces already built up, it gives us that very big advantage to just do a little bit of tweaking and be able to solve a number of use cases without having to really make much of the development effort. So if we talk about percentages, we can say right from 75 to 90% of the work would already have been done. Just that 25 to 15% is that additional development that needs to be done, which is specific to the use case, which is quite critical. And specifically when we are talking about the current scenario where people are still doing more of fence sitting, they are not sure to put significant money onto these kind of projects. Having that end-to-end capability gives us and our partners a very big strength to go out and tap into whatever opportunities that pop up. So this is the Axelta gateway, which we call as i7, a very powerful system. The beauty of this system or this gateway is it's a Linux-based box that it can actually be completely cloud configured. So when we ship these kind of gateway devices to our customers, we don't do any custom coding or any of those things, right? We just send it across to the customer, or maybe our field engineer takes it at the customer site, and then the integration with any of the hardware pieces or any of the nodes happens by defining configuration parameters at the platform, at the cloud level itself, which gives us a very strong ability to build out a small use case but have the extensibility for future use cases. The entire firmware can be updated from the cloud, as well as it's a pretty secure system that we use. This is how the gateway looks like. Similarly, we have this Osmosis platform that we use. It's a big data analytics, machine learning enabled system, supports multiple protocols for ingesting data. Uh, now, again, one of the key aspects of this platform is that it is completely metadata driven. What it really means is that different use cases require different behaviors. So the entire platform behavior can actually be configured without any significant coding to be done by defining those metadata fields, which again gives us a strong ability to go out and build out use cases without any significant changes on the code, which often are very expensive and causes people to kind of abandon a lot of their attempts on IoT. Now, in terms of the scope of solutions that can be done, and then that might not be very specific only to our ecosystem, which we call as osmosis, but in general, we see there is a good amount of traction and requirements coming in three core areas. One is industrial IoT or manufacturing. The other is in smart city applications, or we might also call them as, wide area network deployments, as well as in enterprises trying to either create connected products or transforming their business processes through the digitization process. So these are three core areas where Axelta operates mostly in a B2B scenario. And as we'll go about, I'll explain some of the use cases that we do to kind of get a better understanding of the various possibilities in this space. Some of our customers, this is not an exhaustive list, but some of the, you know, the big brands, they are attached with us for the solution requirements. Now, if we look at the landscape, current landscape, there are specific issues that I briefly touched upon, but I'll go into more specific details now that businesses face before they can start off their journey. Okay, and we'll then see how we can address those issues or concern. Now, the first one is about identifying the opportunities itself, right? Because the scope of using IoT is so enormous that a lot of time they are not sure on where to begin, what use cases to pick. Okay, so that's one of the biggest issues that they are facing. What all are the possibilities? How do you prioritize those opportunities? The number of proven use cases are also limited. It's not that another of their competitor or someone else has already tried that out and gained benefit from it. So they are possibly one of the early movers in that space, which can be a bit unsettling for them. So this is where our education and the consulting role comes in, because we don't go in, okay, you tell me your requirement and we'll do the solution for you. We say we'll walk that journey along with you. We help them get better understanding of IoT, as well as in the consulting mode, help them create laundry list of possible opportunities and pain points and help prioritize with them. Now, the next part is you've identified, yeah, these are certain opportunities or areas where I can apply IoT for reducing my cost, reducing the maintenance downtime, improving my expected time of delivery for specific requirements for customer and those kind of things. But you need to make a beginning. Now, the challenge around that is that the current industry standard platforms, let it be Azure, let it be ThingWorks, or any such platforms, they come with significantly high initial licensing cost. They also come up with a significantly high learning curve to understand those complex systems. The number of people who are expert in using and utilizing such platforms are also limited. So a typical, let's say, a ThingWorks license might cost you close to 15-20,000 US dollars, right? And a lot of businesses are not in a position to in initially budget for that kind of a cost, because they are still trying to figure out. The second challenge in terms of beginning that journey is that there are niche players. They say, okay, I know platform, but I don't have the hardware. I have the hardware gateway, but I don't know sensors. I know sensors, but I don't know platform. I know platform, but I don't know how to do big data analytics to draw out the predictive analytics for you. So that's where again a entity or an organization like Axelta comes in, wherein we say that yes, we have the necessary IP. We also have a low cost platform which is easily deployable. The learning curve involved is quite limited, as well as we'll help you in that journey, including using our own sensors, hardware systems platform to solve your business use case, which is very, very critical for them to do such activities. Uh, the next challenge or the next phase for them is how to roll out their business, right, their solutions. And this could be startups also. We actually work with a number of startups wherein we leverage our ecosystem. I'll share some examples of that. Now, how do you select what is the right hardware? Should I go with an Intel one? Should I go with a Advantech one? Right? And these are high cost systems that you're using. So helping select what kind of wireless protocol to use, which is future proof, what kind of security systems to build around it, and those kind of questions typically pop up, right? We often come across this scenario where people say, why can't I develop my own platform? I am a IT service provider, I know Java or such technologies, I'll build my own platform, right? Those kind of questions do pop up. Would it integrate with other systems, as well as why can't my existing IT consultant or system development provider provide those solutions? Why should I go for another vendor? And eventually, whether we will be in a position to continue with that journey, right? It's not just about uh, getting them started, but are we taking maintenance requirement? Would it scale for my business needs? Right? Is it future proof in the sense right now I've identified a basic requirement, but as my requirements improve or increase or get more sophisticated, would the same investment in hardware software that I have done, would it be kind of scaled up, as well as can it be transformed for the higher level of requirement? And that's where again the ecosystem that Axelta has built really helps them understand the capability of the system to kind of be able to expect and have the confidence that we can support them in that entire journey. Recurring costs is specifically when we talk about our Indian customers is always a concern, but there again we are able to support because of our low cost model to either include the recurring cost as part of annual contracts that we enter in, or maintain the recurring cost to bare minimum so that they can start expecting good results from their investment before they kind of commit more resources to those activities. Now, moving on, and guys, you can keep on popping your questions in the chat box. I might not be in a position to answer them through the session, but at the end of it, I'll spend 10-15 minutes trying to answer your questions. Now, I had talked about three core areas. One is industrial IoT or manufacturing related. Then I talked about smart city, and eventually connected products and enterprise IoT. So what I'll do is I'll take you through briefly each of these areas, what kind of use cases are possible there, and what all some of the use cases we have done over a period of time. So there are specific areas that as an organization we've done solutions on. We've worked with industries for chemical processes. Uh, Process industries are often a big users and beneficiaries of bringing industrial IoT in there, because for them reliability of the process is very critical. Any breakdown in the machinery or motors or pumps can have significant losses attached to them, as well as quality is a process activity. So getting better insights on the process parameters helps them better control their quality. A discrete manufacturing, textile industry, again a process one, thermal power plant. We work with cold storages and all for their monitoring of their systems as well. Now, in terms of current benefits that businesses are looking for, we would say that the primary one that we see is about production analysis. Okay, so these are businesses, large manufacturing setups who have SCADA systems also in place, but that information that is available is very localized. They don't have deep insight or a concentrated data sitting somewhere on the cloud or at a common place wherein they can draw out a lot of their production process performance, right? They could be related to the overall equipment efficiency, the repair or maintenance related factors like mean time to repair and mean time between repair, how well they are utilizing their resources, uh, whether the quality that they are able to meet as they create those production outputs, uh, there is always a certain variation or variance in them. How do I ensure that I can get a consistent quality for my system? So we are actually working with a process plant wherein they've defined what they call as a golden batch, which is meeting all the right criterias of production parameters, including quality. So that batch would have got manufactured in the right time, consumed the right amount of energy and raw material, and the quality of output was also perfect. Now they've identified that batch number, let's say XYZ, is a golden batch, but the next batch that comes out is actually a bad batch. Now, what were the factors that contributed in achieving that golden batch is dependent on a lot of process parameters. So we are helping this business or this manufacturing setup to first of all capture and get all the process parameters, then developing the necessary correlation between those parameters and figuring out what all are those factors which are significantly impacting that. And once we've identified that, how do we control it in an effective manner to be able to achieve those golden batches more consistently? And like I had said earlier, this is the entire process that we follow: analysis, planning, pilot, and then the eventual rollout. So I'll go through these slides very quickly because there's a lot of content here and I would like to cover all possible scenarios. But industrial IoT is about consolidating the data, which could be about various manufacturing equipments that they have. It could be various resources, both human or otherwise, and getting their tracking information, generating the production information quality as well as energy consumption. Being able to visualize and see this information in the real time on their web-based dashboards as well as mobile-based dashboards is the first level of requirement that we often come across with, and that itself can give significant benefits beside predictive and other aspects. Defining certain rules and triggers on the platform side to trigger notifications in case some of those parameters are not in the right stage. It could be related to, let's say, too much of an idling of a vehicle, or it could be certain process parameters of a boiler or any such entity to monitor on a regular basis and trigger alarms. And of course, some analytical reports might not be too much detailed ones at the predictive level, but basic reports which kind of give insights on their process performance. Integrating these systems with the backend system, very important, because their core business processes happen in these systems. So how do we get either the the current data that's there in such systems, instead of creating or recreating those master records in our system, as well as pushing certain workflow items to these systems to trigger any actions. And of course, the next level, which once we have significant data with us, that comes up is how do we get to a predictive model, predict machine failures, predict maintenance, preventive maintenance requirements, and then such kind of things. So this is how a typical dashboard looks like. I'm getting information on the overall equipment efficiency in terms of availability, in terms of performance, as well as quality parameters. Continuously getting that across different machine processes, and being able to, in the real time, showcase it to the decision makers so that they can take their decisions. Uh, Now, this is how the entire system works. I guess a lot of you would already be familiar with, wherein we integrate our hardware pieces, nodes, and all into specific machine equipment, or maybe talk to their SCADA system, or maybe talk to their uh, PLCs, and get the data all across to the platform, and be able to show trend charts, and some SCADA related views also. So some other examples of possible reports that people can generate, it could be more detailed reports or real-time dashboards on the performance on a mobile app itself that can be generated. So that was about machines. Then it could be about your assets also, right? Real-time tracking of your vehicles. We are working again with a manufacturing setup which is got a number of its vehicles which are company owned. How do you kind of track their proper utilization? How is my fleet performing? Whether the drivers are behaving properly or not? Do they need to be maintained? So we have hardware devices which connect to the OBD2 port of these vehicles and are able to extract a lot of such insights about the vehicles. We also work with companies on warehouse management, which is again an important aspect of any manufacturing setup, because typically almost like 20 to 50% of the capital, working capital of businesses are actually blocked in finished and in process inventory. And by digitizing and leveraging IoT, you can kind of release a lot of that blocked capital and utilize it for your growth and other things. So we are working with industries wherein it's not just about getting real-time insights on their finished inventory, because their processes involve significant smaller processes. How do we get insights by deploying counters at each and every machine level to extract out the production, but also the in-process inventory information? And once you have all that insights with you, you can then go about and see how you can optimize that. Your workforce also is an asset. So there are solutions which can be used for ensuring that workflow activities for your workforce, whether it might be for a business process or it could be for your manufacturing process, uh, automatically schedules dispatched to them, some kind of forecasting done for your workforce requirement, and be an ability to track the workforce, but also empowering them to perform certain workflow tasks on the go. And while doing that entire exercise, collecting a lot of data or insights in the workflow process to further optimize the performance. It could be energy consumption. Again, a big concern for most of the businesses, wherein they spend a significant amount of their overall cost on energy. And typically, we've seen that if we are able to measure the energy consumption patterns, both in terms of the actual production time, but also in lean times, there are a lot of optimizations that can be achieved by. One of the example is we were working with a process company where they have two compressors. uh, the second compressor is a backup one, though each of them has sufficient capacity to be able to uh, furnish and make available the necessary compressed air for their entire plant. But often both the compressors were getting used, which was peaking their energy consumption. And by deploying specific energy monitors as well as pressure, dew point, and other sensors in their plant, we were able to reduce a significant part of that cost. So a lot of various possibilities. I've talked about quality control. That's very important. So being able to consistently get quality out by putting sensors on that manufacturing plant and getting a lot of process information, which enables us to kind of get more consistency as well as find out what could be the root causes and resolving them. And eventually, I guess that's a more mature use case once we have sufficient data, being able to predict maintenance activities. Okay, so the biggest challenge that most of the manufacturing setups they face is that some of their critical machinery, mostly the rotary equipments, they could be pumps or motors or any such things, they conk off at the wrong time, right, which completely derails their entire production process and leads to significant losses. So by putting sensors and being able to analyze the data being generated, let's say on a motor, I can put energy monitor, which gives me the peak current, but also a lot of harmonics related information, a temperature sensor, a vibration sensor, and such kind of sensors on the motor, which we stream into the cloud platform and define certain thresholds, but also most importantly, try and see if there are any correlation between the workload, between the failure points, as well as the process parameters that we are able to draw out by putting these sensors on these motors. So some data points which are quite stark in nature, right? That by deploying IoT-based predictive maintenance, unplanned downtime can actually be reduced almost like 60 to 90%. The excess capacity that you need because of this unplanned downtime can also be reduced. Rework can be significantly reduced because you are able to maintain it more consistently. The life extend significantly. The cost of failure and recall exposure also uh, reduces significantly. So this is how a dashboard looks like. This is like different machinery or different processes, how that process is operating, their various process parameters, gives us a very good insight into uh, the production process. So what you see right now is a solution we've done for a textile company, wherein we've retrofitted sensors on their machinery to help get the production analysis for them. So their machineries are like very old and don't even have PLC or SCADA based system. So we are actually right now deploying specific sensors on their plant to be able to get more insights on their production process. All right. So the next piece in the game is light manufacturing. Uh, a lot of enterprises can leverage IoT for solving or either improving their business processes, or actually go one step ahead wherein they can disrupt the market by providing connected products. Okay, so that's very critical for them, and then we work with businesses on both the sides, wherein we work with a company for making their uh, vending machine IoT enabled, a connected vending machine. We work with an elevator company to make it connected elevator, and a lot of such different very varied use cases that we have done now. The key for a connected product is that again, the process cycle remains the same, and being able to quickly do a POC which kind of validates their business assumptions, because when you are going for a connected product, you are making a lot of presumptions of how the customers would perceive it. So working with them to quickly get those proof of concepts out in the market, which gives them that confidence that yes, there is sufficient market for it, plays a very important role. So just to give a perspective or an example, we worked with a company, in fact it's a startup, which has been providing massaging equipments on a capex basis, in the sense anyone can go out and buy that out. Now they are changing the game, wherein they are saying that we are going to now not just sell these massage equipment, we are actually going to lease it out. We are going to charge the end customer or the channel partners for the usage, and the entire ecosystem, including the hardware which controls these devices, the mobile apps which provide the connectivity, as well as the backend system for invoicing, customer relationship management, accounting, has been developed by Axelta, which is enabling this company. It's actually right now in the process of patenting that entire model, as well as going for VC funding, has been done by Axelta. So a lot of possible use cases. Now these use cases could be for a massage equipment, it could be for a medical equipment, they could be for a water supply, they could be for a lot of different possibilities that are there. And there is a significant business model disruption that is happening, quite similar to what, let's say, an Uber did to vehicles, right, or an Ola did. That was for vehicles which were significantly costly. But now, with the technology available and with organizations like Axelta, you can even do the same thing for a product which might just cost you 10,000, 20,000 Indian rupees. So this is how the game is changing, wherein we are moving towards things as a service model, where now in future, instead of selling uh, even white goods, businesses will be selling or leasing out, and the customers would be charged based on usage on a consistent basis, as well as the data gathered from that exercise would also be further used to kind of provide additional value added services. So this is the use case we've developed for that massage equipment supplier, wherein we've created the hardware, provided all those necessary pieces in that ecosystem. Connected weighing machine, connected refrigerator, connected medical device. I'm not going into specific use case scenarios, but yeah, we've done all this. Okay, now quick time check. We have just 10 minutes left out, but I'll quickly take you through the smart city use cases also, and then we will get to question and answers. So some of the use cases we've done in the smart city, or I would say wide area network kind of scenarios. They are smart parking. We have a very interesting solution that is deployed for guard security guard patrolling, passenger information system, smart metering, smart street lighting, a lot of various different use cases. Now, this is the use case which we've deployed for smart patrolling, where we uh, deploy our hardware devices at specific points. We use beacon as the mechanism to identify the security guard and define certain schedule for these guards. This could be at a city level. This could be we have currently deployed it for a educational institution which has almost like a 500-acre campus, and they need to make sure that the guards are doing the right patrolling. So our hardware device include, along with the necessary cloud-based system, is enabling them to schedule those things, as well as for them to be able to follow that to ensure that the guards are doing their job. Smart parking, a known use case. We have the necessary pieces to be able to do that. This smart parking could be outdoor, or it could be indoor parking also for corporates and business establishments, because parking is often a challenge. So a mechanism which enables uh, the employees to book their parking slot and ensure that they, when they are traveling or coming on a vehicle, they get that parking slot. Smart bin, another application which is for waste management. Then we have LED lighting and a lot of other such solutions. So the scope is enormous. I'm just covering some of the use cases, and I would like to now open the discussion for more questions in case you have any. So, are there any quick questions that I can try and answer? If there are none, then I would wrap up the session. I would like to thank you all for your active listening, and we would love to hear back to you to us. We can be reached either via our website, or you can drop us a note at this email address, and we'll be more than glad to help you out in that process. Thanks, Shobit.